start. Hello students. So this lesson is all about solving the exercise 1.1 from your NCERT book. Okay. The questions are easy, but I'm going to tell you how to approach each questions, and I'm also discussing the questions from your example so that once you're done with all these questions, you don't have to do anything else in order to cover up everything from part 1 of this topic. Okay. So the first kind of questions you have is the justifying questions, where you have to justify a statement. Okay. So they'll give you something like this. Every whole number is a natural number. Now think about this. Whole numbers are the ones which represent something as a whole, and when things are not whole, we write that as 0. Yeah? But natural numbers are that we use naturally to count. So natural numbers, they always begin from 1, while whole number begins from 0. So do you think it's a correct statement? It is definitely a wrong statement, because every whole number is not a natural number, because every other whole number except for 0. Yeah, 0 is an additional member when it comes to whole numbers. So therefore, it is not true to say that every whole number is a natural number. Answer is false, because we have to say that to justify this answer, you will say that because 0 is a whole number which is not a natural number. Alright, so that is how you would justify your answer. Next question. Every integer is a rational number. Now, as I told you, rational number means anything that can be represented as a ratio or as a fraction, where both the fractions or both the numerator and denominator should be integer, but this denominator should never be equal to 0. That is how you define rational numbers. Every integer is a rational number. Integers are just the ones that are going in both direction, negative, positive, and 0. So they are all whole numbers, or integers are supposed to be just the whole numbers, all whole numbers along with your negative numbers. Okay. So yes, it is true, because every integer, as in -2, -1, 0, these numbers, they all can be represented as yes, I'm fine, and I hope you will learn something from this video. Yeah, and you see in this question, it's very simple, because every integer is definitely a rational number. Because to call something as a rational number, you want to represent that number as a fraction. So every whole number or every integer here can be represented as a fraction. So the answer is true. So when it is true, then you don't have to justify that, isn't it? Because it's a true statement. And every integer is a rational number. Yes, it is a true statement. Okay. Next question. Every rational number is an integer. Now they're talking backwards. Yeah. Every rational number, think about rational number, think about any fraction or a decimal. Is that an integer? No, it is not, because to be an integer, you have to be only negative or positive or 0, but you have to be whole. You cannot be a fraction if you want to be an integer. So therefore, it is a false statement definitely, and we will say that no, it is not true that every rational number is an integer. For example, you can give an example to contradict the statement. Whereas, the example you could give is, like, let's say, for example, 3 by 2. 3 by 2 is a rational number, but it is not an integer, because upon solving 3 by 2, you get 1.5, which is not an integer. Okay, as simple as that. So this is what exactly the kind of questions you have from this first exercise, and the first exercise is kind of easy on you. All right. Let's try the next question. I think you can answer me this question without my help. Every natural number is a whole number. I showed you in my previous lesson that I made a diagram, yeah, where I showed you that every counting numbers are your natural numbers. So when you bring a new member 0, then you get the new family called the whole numbers. Which part? All I'm saying is every natural number happens to be inside the whole number set. Okay, so if whole number is a bigger set than natural number, because whole number has an additional member. So this is again a true statement that every natural number is a whole number. Every rational number is an integer. If you want me to repeat this part, well, I can do that for you. Rational number is just anything that you can write it as a ratio or as a division form. So usually as a fraction. Okay, that is the definition of a rational number. So you want anything as a rational number where this a and b are individually integers, but remember that the denominator should never be equal to 0. I'm sure you have tried this in your calculator. If you put 30 divided by 0 or any number divided by 0, then it gives you math error. The logic is you cannot divide by 0. You try doing by yourself. 0 divides any number, 1000 if I write. How much do you want to write? 0 times 1 million, whatever you want to write, it's still 0. So it is not valid to divide by 0. Yeah, it makes sense to me. I hope it does make sense to you as well. So every rational number is an integer. Every rational number is an integer, so logically every fraction cannot be an integer. So that is the reason why I said this statement is false. I hope that made sense to you, and I hope you got this. This question is done. It is a true statement, and well, we are done with this. Every integer is a whole number. My goodness. Again, as I told you, I showed you this family thing, isn't it? I showed you the smallest family of numbers we have is our natural numbers. Then we have whole numbers counting or including the natural numbers with a new member 0. And then a new family comes where I want to include all natural numbers with all the whole numbers, and that is now called as integers. So this is integers. I told you it's denoted by Z. Okay, it comes from the word zalin. It's a Greek word. So, which means to count. So that is the reason Z represents all integers. So every integer is a whole number? No. Whole numbers are supposed to be the smaller set, or whole numbers are smaller family than integers, right? So every integer cannot be a whole number because integers are lying here with negative sign, and that do not represent whole numbers. So the answer is false. Why? Because we can give an example of something that contradicts the statement. We can say that -3 is an integer but definitely not a whole number. Well, I can speak Hindi, but it is definitely bad. That is the reason why I like to stick to English, and I hope I'm still making sense. Next question. Every rational number is a whole number. Again, they have something very similar. Rational numbers are whole numbers? No, because whole numbers are just the ones to represent something as a whole, while rational numbers can be used to represent any parts. So rational numbers can represent both parts and whole, while whole numbers represent anything that's just whole. So therefore, it is wrong to say that every rational number is a whole number. It's a false statement. Okay, how would you justify it? Because every rational number, you can give an example. When it is false, you can give one single example of contradiction. You can say that 3/2 is a rational number but not a whole number. Yeah, so there are so many, infinitely many examples like that. Next question. Is 0 a rational number? Well, to call something as a rational number, the definition of a rational number is something I can represent in the form of A upon B. B is not equal to 0. Okay, so if you are interested in knowing where I am from, well, I'm from Sikkim. Okay, and coming back to this question, I want you to understand whether 0 is a rational number or not. The answer would be yes, 0 is a rational number. Why? Because 0 can be represented as a part or a fraction by writing it as 0 upon 1, where both 0 and 1 are integers, and my denominator should never be equal to 0. So 1 is not equal to 0. Okay? This is the definition of rational numbers. Any number represented in the form of p by q is a rational number, where p and q are integers and q is not equal to 0. Okay? That is how we define any rational number. So yes, indeed, 0 is a rational number. Okay? That is how we can do these questions. Now, apart from this justifying statements and figuring out whether something is a rational number or not, there are questions which talks about finding rational numbers between two given rational numbers. Okay, and there is a specific way we can approach questions like this depending on how many numbers you want to find. Let's say if the question was asking you to find one rational number, what would you do is, to find one rational number, you would just find the average of the two. Finding the average would be just to add them up, 1 and 2 added up together, divided by 2. Yeah, that is how you could find the number lying between the two values. And now the standard way of doing this is, what do? They'll take the two numbers, you'll add divided by 2. So it gives you now 3 by 2. And now what do? You take one of the numbers, 1 and 3 by 2, take their average again, because you want to keep on finding the middle value. But if you'll ask me, this method is a little boring for me. Why? Because now I have a whole number to add to fraction and then further divide by 2, and again I'll take the same value 3 by 2, add it to the other number 2, and then find what's in the middle of the 2. It is kind of boring, trust me. Okay, because the other method I'm going to tell you will actually find, or it will actually help you find the exact number of middle values that you want. As I told you, when I would have asked for one number, then what would I do is I would add them up and I would divide by 2, right? I would divide by 2. So the thing is, now what we'll do is, if they'll ask you for finding 5 rational numbers, what we'll do is we will take the value 5 plus 1. Okay, add 1. Why? I'll show that to you. So 5 plus 1, 6. Now what do we do with this value 6 is, I will times and divide by 6. So any number is balanced if you multiply and divide by the same value. So I'm multiplying the first number 1 by 6, dividing by 6. Similarly, I'll take the second number, I'll times it by 6, divide it by 6. I'll go back to that example where I was talking about finding one rational number. If you were to find one rational number, you would actually, following the same method, what you're doing is, you are finding 1, so 1 plus 1, 2. Now you're multiplying and dividing both numbers by 2. 1 times 2 divided by 2 and 2 times 2 divided by 2. Okay, this is 2 divided by 2 and 4 divided by 2. What lies in between, you exactly get one value, 3 by 2. See? What lies between 2 by 2 and 4 by 2? Clearly it's 3 by 2, right? Look at this question. Similarly, if you want to find 5 rational numbers, I took the number 5. I want to find 5 of them. So I'm going to multiply the number 1 higher than that particular number they're asking me to find for. They're asking me 5 rational numbers. I took 5 plus 1, 6. I'm going to multiply and divide both numerator, here in this case I just have 1 and 2 given to me. So I'll multiply and divide by that number 6. Gives me how much? 6 upon 6, 12 upon 6. So what lies in between will definitely be 7 by 6 is one number, 8 by 6 is the other number, 9 by 6, 10 by 6, 11 by 6. It's actually very interesting. Why? Because I found the exact number of numbers they're asking me to find in between. Okay, I got exactly 1, 2, 3, 4, 5 values between the two numbers. 6 upon 6 is 1 only and 12 upon 6 was 2. That is, we are still between the same two numbers the question told me to look for, or we are finding 5 natural numbers between 1 and 2. This is what you could exactly do to find exact number of fractions in between the values. Okay, so now don't forget, you want to go ahead and simplify wherever possible. So as in, just a second, yeah, 7 by 6. Okay, all right, sorry, I think my working must be so because I got these numbers, yeah, 7 by 6 is still 7 by 6. You want to keep it as it is. 8 by 6 can be simplified. You can simplify 8 by 6 to 4 upon 3. 9 by 6 can be simplified to 3 upon 2. 10 by 6 can be written as 5 by 3. 11 by 6 as it is. So these are different, these are the exact 5 fractions lying between 1 and 2. Okay, so that's it. That is how you can figure out finding the exact number of numbers lying between the two given numbers. Let's take more examples like this. I hope you will understand and you will not have a problem. I see. Find 6 rational numbers between 3 and 4. They are asking for 6. So what do? We'll think of the numbers 6 plus 1, 7. Okay. What do? Is I'll take the two numbers given to me, 3 and 4. I times by 7, divide by 7. Times by 7, divide by 7. 3 times 7 is 21. So 21 by 7. 4 times 7 is 28. So 28 upon 7. I got the two fractions. Now 6 rational numbers. Think about the two numbers 21 and 28. What lies in between is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. See? Between the two numbers we wrote, 21 and 28, we got the exact 6 numbers as they are looking for. So I found 6 rational numbers lying between 3 and 4. Very easy. Don't forget this technique, and it's super helpful because it gives you answers in just one step, I call it, okay? Because you don't have to go ahead and find the middle value over and over again. This saves a lot of time. Now, what if they ask you for a question like this, where they give you a fraction, find 5 rational numbers between 3 and 5. We are going to follow the same technique as we did here. What was the method? Whatever number they asked me to find, 6 numbers they wanted me to find, I added 1, and then whatever number I get, I multiply both numerator and denominator. Because the numbers were just 3 and 4, there was no existing denominator, right? So I took my denominator as my new value, just 7. Whereas if you take this question now, find 5 rational numbers between 3 by 5 and 4 by 5. Interesting. The method is still the same. I want to find 5 rational numbers. Which question should I repeat? I just repeated the question. Okay. Find 5 rational numbers between 3 by 5 and 4 by 5. They are asking me for 5 rational numbers. So what do? Is to find 5 rational numbers, I will just take the fraction given to me. The technique is the same. I want to find 5, so 5 plus 1, 6. I have to take 6 as my multiplier, and I'll multiply 6 to both numerator and denominator. Take the other number, 4 by 5. I want to find 5, so I'll multiply 6 to both numerator and denominator. 3 times 6 is 18 upon 30, and 4 times 6 is 24 upon 30. So what lies between 18 and 24 will be the numbers with the same denominator. So 19 by 30, 20 by 30, 21 by 30, 22 by 30, and 23 by 30. So the best part is we got exactly 5 numbers lying between the two fractions. Now simplify wherever possible. 20 and 30 becomes 2 and 3. 21 and 30 becomes 7 upon 10, right? Because both are divisible by 3. 22 and 30 becomes 11 upon 15, divisible by 2. So my final fractions or the rational numbers lying between would be 19 upon 30, 2 upon 3, 7 upon 10, 11 upon 15, and 23 upon 30. That's it. That is how you find rational numbers lying between two given rational numbers. So that is it. I have finished, or I have completed all the questions from your exercise 1.1 along with all the example questions, so that if you practice this much from the first part of this topic, you really have nothing else to look at. These are the exact kind of questions you can expect, and the next exercise will be completely different. It's all about irrational numbers and a lot more. It is going to be very new to you. So till now, I hope whatever things we discussed, it made sense, and I'll see you in the next session.